Hey guys, we're back with another installment in a series of proofs of Pythagoras theorem. This proof, number 4, is very similar to number 3, but is significantly simpler and should be easier to follow. I've linked to the other 3 proofs in the description and comment section. So we're here to prove that for a right angled triangle where the hypotenuse is c and the other two sides are a and b, that a squared plus b squared equals c squared, which I'm sure all of you are familiar with. So let's see how we can use the properties of similar triangles to prove this theorem. I'm not going to go into the details about similar triangles. I suggest you look up the term ratios of corresponding edges of similar triangles, which is a property that we're using in order to understand this proof. So let's begin. We have a triangle with edges A, B and C. It's a right angled triangle and the right angle is opposite the hypotenuse. Now the first thing I'm going to do is to give the two non-right angles a value. I'm going to give the base angle the label of capital A, so the value of the top angle must be 90 minus A. Next, I'm going to draw a line that passes through the right angle that is also perpendicular to the hypotenuse. So the angle between this new line and the hypotenuse must be 90 degrees, and this also results in the original right angle becoming a composite angle. But we can easily figure out what these two angles must be. The line we just drew has split the main triangle into two different triangles. Both of the triangles share an edge which is perpendicular to the original hypotenuse, so each of them have a right angle. In the larger of the two triangles we have a 90-degree angle and the angle A, so the remaining angle must have the value of 90 minus A. And in the smaller triangle we know that the angle adjacent to the hypotenuse is a right angle and the other angle is 90 minus A, so the remaining angle must have the value of A. Now let's look at the angles in each triangle. In the smallest of the resulting triangles, the angles are 90 degrees A and 90 minus A, but in the other triangle created by the perpendicular, the angles are 90 degrees A and 90 minus A, and in the main triangle we had before using the perpendicular, the angles are 90 degrees because this is a composite angle, A and 90 minus A. These three triangles have the same angles, so they must be similar triangles. And because they are all similar, we can now use the concept of corresponding edges to show why a squared plus b squared equals c squared. Before we move ahead, I'm going to relabel the edge c because it was split into two by the perpendicular. So we give the length of the right hand side of the hypotenuse the value of c1 and the left hand side c2. And now we can rewrite the value of c as c equals c1 plus c2. Next, I'm going to make a comparison between the main triangle and the smallest of the two triangles we created with the perpendicular using their corresponding edges. If we take the hypotenuse of the smallest triangle A and divide that by the hypotenuse of the main triangle, which is C, that will have the same value as the shortest edge of the smallest triangle, which is C2, divided by the shortest edge of the main triangle, which is A. Now if we use cross multiplication and multiply both sides by a, we get a squared on the left hand side, and both sides by c, we get c times c2, and that gives us that a squared equals c times c2. Now let's do a similar thing with the main triangle and the larger of the two triangles created by the perpendicular. If I take the hypotenuse of the larger internal triangle B and divide that by the hypotenuse of the main triangle, that's b over c, that will be equal to the second longest edge of the internal triangle, which is c1, divided by the second longest edge of the main triangle, which is b. Again, if we use cross multiplication and multiply both sides by b and both sides by c, we get that b squared must be equal to c times c1. And now we have the value of a squared and b squared. Look what happens when we add them together. A squared plus b squared must be equal to c times c2 plus c times c1. But both parts of the sum contain the value c, so we can factor out the c, so that equals c times c2 plus c1. But we know the sum of these two, which is c1 plus c2, equals c, so that equals c times c, and that equals c squared. And that means that a squared plus b squared equals c squared. And so we've found another way to prove Pythagoras theorem using similar triangles. Well, that's it for now. Thank you for watching.